Okay, let's have a look now. So next few questions, we're going to have to draw a triangle for them. Okay, and that side is A, B, C, and here we're going to we'll call that angle there. That's C, A, B. Okay, and we want to calculate here the sine of A, cos of A, yeah, okay, the tan of A, cosec A, sec A, and cotan A. Okay, let's get started. 129. So 129, A is 4, C is 7, and B we don't know, but a quick use of Pythagoras will tell us what the B is. So that would be the square root of 7 squared minus 4 squared, which is root 33. Okay. So they say to use one decimal place when necessary. So that would be 5.7. So what's kind of strange about the answers is that I just personally, I wouldn't use 5.7. I would just use root 33. But looking at the answers, they want the one decimal place, so that's fine. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. And then cosec is the reciprocal of each of these. 7 over 4, 7 over 5.7, and 5.7 over 4. So I'll just check if that's right. Yeah. Tan A, yeah. Cosec, yeah. Sec, yeah. And cotan, yeah. So that all looks good. Okay. Okay. Right. 130. This one is 21. This one is 29. And Pythagoras tells us the other side is 20. Well, that's nice. So that means sine A is 21 over 29. Cos A is 20 over 29. And tan A is 21 over 20. And then that's 29 over 21, 29 over 20, and 20 over 21. So that's 130 done. Okay. 131. A is 85.3. B is 125.5. And then C from Pythagoras is square root 85.3 squared plus 125.5 squared. So that's 151.7. So sine is 85.3 over 151.7. Cos is 125.5 over 151.7. And then tan is 55.3 over 125.5. And then cosec is 151.7 over 85.3. And then 151.7 over 125.5. And cotan 125.5 over 85.3. What is peculiar here is that these answers are decimals, but the 4 decimal places. There's an inconsistency in the answer in here, because in question 129, it's kept as a fraction of decimals. 131, it is converted to 4 decimal places. And then I can see in the next one, 133 and 135, they're natural numbers, which maybe it's because they're a Pythagorean triple. So I think I'll just make a note just to query the answer to 131. Okay, that's 131. One 132. B is 40, C is 41, and then from Pythagoras, we get this side is 9. So sine A is 9 over 41, cos is 40 over 41, and tan is 9 over 40, and then the reciprocal for each of these three. And that's 132. 133. A is 84, B is 13, and then from Pythagoras, square root 84 squared plus 13 squared, that's 85. So that's 84 over 85, 13 over 85, 84 over 13, 13 over 84, 85 over 13, and 85 over 84. And I can check the answers for this one. 84 over 85, 13 over 85, 84 over 13, 85 over 84, 85 over 13, and 13 over 84. That's correct. 134. 134. B is 28, C is 35, and A from Pythagoras, square root of 35 squared minus 28 squared is 21. That's nice because that makes sine A 21 over 35. Cos A is 28 over 35. Tan A is 21 over 28. And then the reciprocals for these. Okay, that's 134. Okay, 135 now. 135. For the following exercise, P is a point on the unit circle. Find the exact missing coordinate value of each point. And B, find the value of the 6 trig functions for the angle theta with terminal side that passes through P. Rationalize the denominator. Okay. Am I still recording sound? Yes, I am. Okay. Let's make a unit circle here. Do shapes. Nice. Okay. One. Well. 1 0 0 1 minus 1 0 0 minus 1 135. Okay. So this first point here is that, oh, and we'll write down what we need here. We need sine A, cos A, tan A, and then we need cosec A, sec A, cotan A. All right, now, this first point here is 7 over 25 and a positive y. So that means that this distance, this base, that's y, and this base is 7 over 25. So we could use Pythagoras to work out the y. So that's square root 1 minus 49 over 20, no, 25 squared is 625, isn't it? So that means the y will be 24 over 25. So basically the triangle is going to be, if we multiply all these sides by 25, that would be 7, that would be 24, that's 25. Although this triangle is bigger than the original triangle, it's all sides are in the same proportion, and it means the trig ratios are unaffected by this, and it'll just be more convenient than having a fraction divided by a fraction. So sine A would be 24 over 25. Cos A would be 7 over 25. Tan A would be 24 over 7, and then 7 over 24, 25 over 7, and 25 over 24. How did they express the answer? Yep. Cos A, 7 over 25, yeah. Tan A, 24 over 7. Cosec, 25 over 7. Sec, 25, sec, 25 over 7. Yeah, cosec, 25 over 24, and cotan, 7 over 24. Yeah, that's right, 135. Oh, and does it say what the y is? Yeah, 24 over 25. Yeah. Okay. Now, 136. So y is negative, so it'll be down here. This is at minus 15 over 17 y. So the triangle would be like here. If I just redraw that up here, that's A. That's A. So this side opposite is a length y. Although y is a negative, so its length would be minus y. And this side here, its length would be 15 over 7. And this length would be 1. Therefore, from Pythagoras, minus y would equal um, 8 over 17. So that means y is minus 8 over 17. And if we just rescale that triangle up by multiplying by 17, so that would be 15, that would be 8, and that would be 17. 15 being the, adjacent, and then, 8, 17. Yeah. Yeah. Okay. So sine A would be 8 over 17. Cos A would be... Oh, now we have to be careful with the signs. So in this quadrant here, only the tan is positive. So these answers are negative, and these answers are positive. Okay, so cos A would be 15 over 17. Tan A would be 8 over 15. And then this is 15 over 8, 17 over 15, and 17 over 8. Okay. 137 next. One, three, seven. X is negative, Y is positive, so it'll be like here. Oh, yeah, yeah, yeah. Just want to be careful with the signs here. That's X, and then root 7 over 3, where X is negative. So if we draw our triangle here and call that A, but let's just establish the signs first. So only the sine is positive. Okay, so if we draw a right angled triangle, this side is X, this is root 7, root 7 over 3, and then that's 1. So Pythagoras tells us the X, well, that's technically negative X if we're talking lengths. So root 1 minus 7 over 9, so that's root 2 over 3. Okay, so multiply everything by 3. So no, that's what minus x is equal to. So x is equal to minus root 2 over 3. So this would be root 2, root 7, and 3. Okay. Sine A would be root 7 over 3. Cos A would be root 2 over 3. Tan A would be root 7 over root 2, which would be root 14 over 2, wouldn't it? And then here, that would be positive 3 over root 7, but we multiply above and below by root 7, so that would be 3 root 7 over 7. This would be negative 3 over root 2. And then this would be 2 over root 14. So let's check if that's right. 137. That's right. And then positive, negative, negative, positive, yep, negative, yeah. Oh. Oh. I wonder if that's a typo. The answer says it's minus root 14 over 7. I think that must be wrong. Huh? Oh! Ah, silly me. I can divide above and below by 2. Yeah, okay. That's right. Yeah, that's funny. That's so silly of me. I hope I didn't do that on the last page. Um, failing to simplify. Uh, okay. All right. Okay. 138. X is positive, and that's a negative. So that is x positive minus root 15 over 4. That's a. That's x. The length is root 15 over 4. That's 1. So that means x is root 1 minus 15 over 16. So that's 1 over 4. Okay. And then we can scale that triangle up, multiplying by 4. So that'll be 1, that'll be 4, and that'll be root 15. So sine A is root 15 over 4. Cos A is 1 over 4. Tan A is root 15 over 1. So that, oh, signs, don't forget the signs. A, S, T, C, they're all negative. They're all negative except for cos, which is positive. Okay. So cosec would be 4 over root 15. Sec would be 4 over 1. And then this would be minus 1 over root 15. Okay, so I think that's okay. A, S, T, C, negative, positive, positive, negative, positive, positive, 15 over 4, 4 over, yeah, 1 over 4, 4, 1 over 15. Yeah, okay, I think that's right. Hopefully I didn't make any mistake there. Are we still recording? We are. And that's actually a good place to leave it for today. So that's quite a lot done. 129 to 138 for today. Okay. Okay, that's great. Thanks for watching.